Okay, we have here today a pretty interesting looking integral. We've got the integral from 0 to pi of cosine to the 10th x over sine to the 10th x plus cosine to the 10th x dx. Okay, right away there's something you may notice about this. If I were to make just a very small change to this, if I were to just change this bound to pi over 2 instead of pi, this becomes a really easy integral, and the answer is just going to be pi over 4. Now, how do I know the solution to this is pi over 4? Well, this is actually the King's principle. So this is something you can do in like 2 seconds, because with the King's principle, and we'll go over that a little bit in a moment, after some manipulation, the integral becomes 1. Just imagine we're integrating 1 dx with the same bounds. Well, this is going to be x from pi over 2 to 0, and this is just pi over 2. Well, how did I get to pi over 4? Well, when we do the manipulation for this, it's actually 2 copies, so we end up dividing by 2 and getting our pi over 4. So this is all what's happening if our upper bound was pi over 2. So the problem is the bounds are actually not 0 pi over 2, it's 0 to pi. So what I'm going to do is put it back and see what we can do. So now with the bounds back to pi, there actually is still a formula for this, but I kind of want to go over it in detail because I have a hard time remembering formulas, and so I just kind of want to go through how all this is going to work. So what I want to do is I actually want to use the fact that we know exactly how to get a solution if this is pi over 2. So we're going to use this fact that if we had an integral from a to b of f of x, and we add this to an integral from b to c of f of x, well, we can combine these with the same exact integrand. We can combine these and write it as an integral going from a to c of f of x. And so with the case we have here, we're actually going to just do this in reverse and take this and break it up on pi over 2. So what I can do is I can write this as going from 0 to pi over 2 of this whole thing. So this will be like our a to b integral. And then for our second one, we're just going to do our b to c integral, which is going to be the rest of our bounds. So we're going to write this from pi over 2 to pi. So now from here, like we said before, we know that this value of this integral here is actually going to be pi over 4. And let's just see how this is done really quick, because I don't want you to just trust me that the answer is pi over 4. I want you to kind of see how it works. So I'm actually going to call this, n, because I'm going to call our full integral our goal I. So we're going to call this integral n from 0 to pi over 2. And then I'm going to make a u substitution here. I'm going to make my u equal to pi over 2 minus x, kind of using our bounds here. And if that's true, then x is going to be pi over 2 minus u, and our dx value is going to be just minus du. And before I make the substitution, one thing I want to look at is we're going to be using the complementary angle formula. And so how the complementary angle formula works for cosine and sine is if we have cosine pi over 2 minus u, that's going to be the same thing as sine of u. And if we have sine of pi over 2 minus u, that's going to be the same thing as cosine of u. So that's going to be really useful in just 1 second when I do this substitution. So what I'm going to do first, we'll plug in our bounds. So looking at pi over 2 at x, that's going to be 0. We plug 0 in here, we're going to have pi over 2. So here for just looking at cosine of x, well, our x is pi over 2 minus u. So we're going to have cosine of pi minus 2 over u. So in the numerator, we're going to have, this is going to be sine of u, but this is still to the 10th power. And then let's see, our dx is going to be minus du. So let me just rewrite that for a moment. And then here, the cosine 10x, this is exactly the same thing. So this is also going to be sine u to the 10th. And now for sine x, this kind of works the same way, right? We plug in pi over 2 minus u. Sine of pi over 2 minus u is going to be cosine of u. So this is going to be cosine to the 10th u. I'm going to take this minus sign and we're just going to use it to flip our bounds. So this is going to put it back to 0 to pi over 2 here. I'm going to do a quick variable change, but this is a definite integral. I can change the variable. So I'm going to change this back to x. Okay, so now we've transformed this thing, but this is still the same integral n. And what I want to do is just add these two together. So we'll have 2 copies. So we're going to have 2n. And when we add these, notice the denominator is the exact same now. I just have it in different order. So when we add these, we're still going from 0 to pi over 2. Our numerator becomes sine to the 10th plus cosine to the 10th here. And then the denominator is the exact same thing, sine to the 10th plus cosine to the 10th x dx. Like I mentioned earlier, the whole integral becomes 1. And this is why this is so easy, right? So then when we integrate this, integrating 1, we're just going to have x from 0 to pi over 2. We plug that in, we just get pi over 2. We divide by 2 on both sides. And so for this n integral, the value is going to be just, like we said earlier, pi over 4. Okay, so now to the main course. This is the more tricky part right here, because now we have our bounds going from pi over 2 to pi on this one. But for this one, it's actually not going to be too different. We're still going to do a substitution. So I'm going to do a u substitution using the upper bound pi. So we're going to say u is going to be just pi minus x is going to be pi minus u, and our dx is going to be minus du. I'll go ahead and we'll make this substitution. We'll bring it down this way. So when I plug pi in here, we're going to have 0 for the upper bound. We plug pi over 2 in. This is going to give me pi over 2. Then before we do the substitution on these trig functions, what I want to do is look at the supplementary angle formula. Just notice we don't have, in our substitution, it's not pi over 2 anymore, it's pi. Okay, we have our supplementary angle formulas over here to the right. Pretty easy to remember, right? We got sine pi minus u is going to be just give me back sine of u. And then for cosine, same thing, but we just need a minus sign in front of it. So starting with cosine, when we substitute in for x, we're going to have cosine of pi minus u. So this is going to give me here minus cosine of u, and this is to the 10th power. Well, because it's an even exponent, this minus is going to become a plus, and so we're going to just end up with cosine of the 10. And so then in the denominator, this one's exactly the same, so this is going to be, this cosine is going to become cosine of the 10th u. And then for sine, when we plug in pi minus u, again, sine of pi minus u is just sine of u. So this here is going to become sine of the 10th of u. And for our dx value, we're going to have just minus du. Same thing with our previous example. I'm going to take the minus sign and use it to swap the bounds around. So now we're going back. We're going to be going from 0 to pi over 2. And now look what happened, right? This thing right here is actually exactly the same as this thing over here. The integrand is exactly the same. Now our bounds changed. We were going from pi over 2 to pi. Now we're going from 0 to pi over 2. Now that's okay, because what happened is this now is exactly the same as this. This thing is the same as our n value, and we know our n value is actually pi over 4. So just to sum up everything that happened here, we have our main integral I, okay? We broke it into two integrals. The first one, n. The second one's this other thing, but the second one turns out to be the same exact thing. This is also n. So we're saying our I value is 2 times n, but we know what n is. It's pi over 4. So all we need to do is multiply 2 times pi over 4, and we get our final solution of just pi over 2. Okay, like I mentioned in the beginning of the video, there is a formula for this. It's a situation where if f of 2a minus x is the same thing as f of x, we can use this principle of basically this 2n situation. And so for our example, like f of x is this, f of x is our whole, f of x is this thing right here, right? And what we noticed was for 2a minus x, a substitution of 2a minus x, where 2a is going to be pi, we noticed when we did that, this was this substitution right here, and it just transformed this integral. If we consider that we took this, we substituted in our 2a minus x, which was pi minus x, we just got back f of x. So this principle worked. And so because this principle here is true, we could transform this without changing it this way. Well, in that case, when the bounds are double, notice pi is twice pi over 2. Well, then we end up with just this 2n situation where we just end up dividing by 2. So what I did is essentially like a long way of doing it out so we could see all the steps. So there is this real shortcut way of doing it and just dividing by 2. But like I said, I have a hard time remembering those formulas, so a lot of times I would just do this out really quick. Okay, good problem. We'll stop it there. Thanks everyone for watching. Please like and subscribe. Have a great day.